Day 2. We talked a little bit about review. Students had mentioned in packet tracers looking at large files, being able to use the filter, include, exclude, etc. Also in the packet tracers we talked about creating a topology. We talked about why that is important to build like a test, configuration, setup, lab before, and then you can copy it to the real environment. In fact, you should try that sometime. Create something packet tracer and copy it to the real switch. SSH, we had a review. They gave us their passwords. Questions? Everybody seemed good. I talked a little bit about learning and content, like in the follow-ups, oh, that's really great, or, practice makes perfect, or, certain things that, we don't want you to say the same thing all the time just to put something in. Make sure you look and get some content into your comments, your original comments, and your remarks. Take a look at the objectives and so forth. Which ones seem to hit it home rather than say, oh yeah, everything was pretty easy, I think I got it all. A real plus, a couple students mentioned about working together. That is key. Working with your peers, being able to solve a problem. We talked about the whole idea, using my son as an example, video game they're currently working on, but how much you can learn by accessing different groups that have the same interests as you via the internet. Then the students, they were to clear the switches, make sure they were clear, and then they did some basic configuration, host names, checked their neighbors, did the basic configs, no IPs yet, we covered those later. So then we looked at our environment, okay, and we talked a little bit about switching fabric. We have a multi-layered switch here, and we've got a layer 2, I just said an L2, layer 2 switch, and this was a multi-layered, but we're using them just as layer 2 switches right now. And then talk a little bit about they layer this. We have access. We talk a lot about access in information data assurance. And then distribution. So here's how people get in, and then here's how the traffic is distributed. For example, maybe going to a server, or eventually going out to another network or the internet. I gave the example, we hook up a laptop and access. We also talk about the importance of access, let's say on a Wi-Fi, is it a guest, bring your own device, bring your own app. We talk a little bit about literally hundreds and hundreds of people that access the Wi-Fi at night in the middle of the day. Okay, so how does the switch manage this? We hook up a laptop or a device. The switch remembers the MAC address, puts that in content addressable memory, which is really fast. And so these ports remember which MAC addresses went through. So when this is trying to reach the laptop, we did probably do address resolution protocol, where we match up an IP with the MAC, and then we get the MAC address, then we send, communication gets there via the MAC address, and then comes back, it hits here, the MAC address sends it to the right device, and so forth. Same thing for the access point. Then we took this whole idea and we split it into VLANs. We said, okay, here I've got a purple VLAN, VLAN 10. Maybe here I have a green VLAN, VLAN 20. So the green can talk to the green, and the purple, maybe I use another color here, the purple can talk to the purple. But they can't cross over without getting routed, which we talk about tomorrow. So a couple key things. This whole area is a broadcast domain. And there can be a lot of devices in there. So every time a device needs to send something somewhere, it does that. It does an ARP, Address Resolution Protocol, uses the IP to match up with a MAC, and then it can send the information. So that broadcast goes to everybody. Well, we can split it into VLANs. Each of these VLANs, for example, the green and the purple, they create their own broadcast domains. So one big one, it's better to have many little ones. And so the network runs much more efficiently. You can actually do more security of, like for example here, the green can't get to the server because that's in the purple based on the numbers. And just managing the network. How does the information go through here? It goes through a trunk. It's the same thing. This here is a trunk, and what a trunk does is that when the frame gets there, it tags it. If it's purple, coming from purple, marks it with a 10, goes through, and then over here it looks at that tag again, that's a 10, and it says it can go here or to the purple out there, based on that number. Yeah, we did a little review of the OSI model. Then to wrap up. This is what our configurations basically looks like. We have a connection to a router, and actually we have 4 connections to one router, 4 connections to this router, and 1 connection to this router. Routers are connected out. We'll simulate going out to the internet. And then this is what each student has. Okay, this setup here. So they worked on closing a trunk down, and then using this one for their trunk. Had a few issues, so we talked about devices 25 to 39. I believe those are 3550s. You're going to have to do some encapsulation .1Q. We'll look at some specifics on that tomorrow. 3560s should default to that. Pretty easy to get a native VLAN mismatch depending on how you have your VLANs and so forth. So you can show interface trunk to see your trunks and see if they're up. The 3550s auto negotiate. So we talked about looking at that. We have this dynamic trunking protocol that automatically sets up trunks if it's on, or you can specifically set it to trunking yourself. So the students did some work in the lab, a little confusing because they had to make some adjustments, but we're going to take a look at those for tomorrow. And we went and assigned addresses, so the students knew what addresses they assigned to their routers going out. So then eventually we hope to have connectivity between each other. Okay, great start. Make sure if you have questions to let me know.